So I think we'll start our presentation now. Thanks for joining us. So welcome. We're going to chat today about interactive plot quizzes, a new feature in Wolfram Alpha Notebook Edition we've been working on. My name is Anne-Marie Torreson, and I'm been working for Wolfram for a little over a year. I'm on the Wolfram Alpha math content team. Before joining Wolfram, I was a high school math teacher, and I earned my master's degree in teaching secondary math. So I really enjoy working on tools that are useful for K through 12 classrooms. So this project has been really fun. And along with me is the wonderful Jeremy Stratton Smith.
Hi, everyone. I am just going to be giving the overview here before handing things back over to Anne-Marie, but I am also a Wolfram Alpha math content developer. I've been at Wolfram just under 3 years now, and have worked on a bunch of different things, but this has been sort of one of our new and exciting projects. If you've been to some of the other Wolfram Alpha Notebook Edition or Wayne related talks, you probably have heard a little bit about these interactive plot quizzes, but yeah, we're really excited to show these off and hopefully get some good feedback and suggestions for where to take this in the future as well. So what we're going to be talking about today, we're just going to give a very sort of surface level at first overview of what are these interactive plot quizzes. We're going to talk through sort of the scope of what we've implemented so far, some of the features, and sort of a little bit of the technical sort of, what are the particulars of how these are working and things that we like about them, and then go into thinking about where we're going in the future with these, because there's a lot of avenues that we could take, and we're excited to be able to share those with you, and then open up for questions and feedback. And with that, I'll hand things back over to Anne-Marie.
Thank you. Okay, so starting with our overview, what are interactive plot quizzes? Well, interactive plot quizzes are sort of like part of a progression of us trying to expand interactive content in general, which we can really do in the Wolfram Alpha Notebook Edition, or Wayne, we call it for short. So we've been sort of working up toward this. We have a few other functions, resource functions available in Wayne, like curve analysis, which I'll show here. I wonder if this is a curve analysis and manipulate plot are all examples.
As Anne-Marie was saying, we've been working through the scope of what kinds of content we're able to provide, particularly with a focus on interactive content, recognizing the importance of being able to interact with things for building intuition and deeper understanding of mathematics concepts. So we started off with things like this function, which is sort of what we would call a super function. It pulls together lots of other functionalities to give you an analysis of a particular curve with the ability to turn things on and off. You can choose if you want to see the roots, the inflection points, if you want to see the integral of your input curve, etc. From there, we've also built up things like manipulate plot, which has been a crowd favorite amongst our users, as we've heard, that you're able to not only just get a regular manipulate, but we do some processing behind the scenes to be able to do some of the things that you might be familiar with on a graphing calculator, where you can dynamically update the range and the viewing window and so on. All of these are great for building intuition, but they don't necessarily have any sort of assessment or sort of deeper, like getting at the heart of a problem that we might want in a math world. So we've developed these interactive plot quizzes, which generally look along the lines of what you see here. There's a title, there's a problem description, there's a plot with some sort of interactive pieces that you can move things around, for example, like this. And then there are some buttons down at the bottom, including some display options. So the display options include things like if you want to see a table of points on the curve, or if you want the points, the locators here to snap to a grid instead of just jumping, or instead of being completely free floating. With that, Anne-Marie, let me know if you're back up and running and we can transition back at any point.
I think so. Okay, so the interactive plotting quizzes are you can get at them from a few different avenues. In Wolfram Alpha Notebook Edition directly, there is a beautiful button up on the toolbar on the right side where you can click them and see them sorted into their categories of different topics. You also can, within Wayne, just in an input cell, ask to be quizzed on a certain topic, and this should, let's try it again. There might be something wrong with my Wayne. But theoretically, this would give us a nice interactive plotting quiz. If you're having the same trouble that I am, and for some reason that's not working, you can also access these through the Wolfram function repository directly in any Mathematica notebook. So as a resource function, I can look up this quadratic transformation quiz. And those all look similar. They all have a prompt and then a plot that you can interact with. So the idea is that students and anyone, students of life, really can learn more when we're interacting with and manipulating and experimenting with something that moves in response to us. And so being able to tactilely on a computer screen, adjust the points and experiment to see how things change as you're moving different parameters, we hope is a really good learning tool. And then, as Jeremy was mentioning, there's this second level of interaction where you can check your answer and get feedback and get a grade. So all that should be built into these interactive plotting quizzes. We have sort of at our first pass of adding these quizzes, we've tried to sort of get a sampling of topics from high school through early college. That includes some plotting, some data fitting, and then a few early calculus topics. Jeremy, I might just ask you to open up a Wayne notebook since mine isn't working, and you can click that button, which we showed on the previous screen. I'll stop sharing. And you can see the array of topics we've covered, and we're hoping to keep adding more. We're currently working on adding more, and when we ask for feedback at the end, we'd love to think about other topics you'd like to see covered.
As Anne-Marie was mentioning, in Wayne directly here in Wolfram Alpha Notebook Edition, there are 3 new features. There's a demonstrations browser. There's some starting point notebooks, which sort of give you examples of what kinds of content we're able to cover in Wolfram Alpha Notebook Edition. And then finally, we have these interactive plot quizzes. And I'm going to shrink down here and do that. And so we've broken these down into 4 main categories. There's just straightforward plotting curves. There's building functions through other functions. There's calculus concepts and understanding data. And if you go ahead and click on any of these, it opens up a great browser here where you can say, we want to look at sinusoid plot quiz. So this is a function here that is going to give us a prompt that is related to plotting a sine curve. So here, adjust the given points to form a sinusoid with an amplitude of 5, a period of 3 pi, and a midline of y equals 2. So I'm not going to do that one right now. We're going to do a few more examples in just a moment. But overall, this is the idea of what we're working on here. So as we go through the features here, I'm going to talk, we're going to look at some examples concretely here. I also encourage you as the viewers to go ahead and download the notebook from Pathable and be able to play with these yourselves, okay, as we're going along. So for those of you who are not familiar already, one of the other products that sort of fits under the Wolfram Alpha umbrella is the Wolfram problem generator. There's a link here to go ahead and look at that. But this is sort of the web take on programmatic random problem generation. And there's a whole range of content within the math world that is covered by the Wolfram problem generator. But for one of the big pieces that is sort of missing with that is that it doesn't have the interactive visual component of plotting. So this is sort of our take on that, where we're still being able to, we're taking the idea of the random problem generation. So for example, here we have our quadratic description plot quiz. It gives us a description of a quadratic curve. And as I click next problem here, you can see we get a number of different ways of describing a curve. Here we have a factored form polynomial. We get another factored form polynomial. Here we have a y-intercept and roots. And so you can get a whole range of problems, and we've constrained them in such a way so that a high school student who is first interacting with, or a middle school student who's first interacting with this, these are the kinds of functions that they're going to see. We don't have anything where the y-intercept is 1 million and the roots are at negative 10,001 or whatever, something that just gets hard to interact with visually here. So yeah, so all of them feature all of them exhibit this feature of having the random problem generation. Next, and we're actually going to walk through, not this one because I'll do just a very brief thing here because it would take too long. But here we have a slope field quiz, and I'm going to show off the automatic grading and feedback here. So here we have draw the slope field defined by this this equation, and let me see here. So if y is -3, we're going to have a slope of, if y is -3 and x is -1. See, this is why I'm going to do a different problem. I'm going to do one that's easier. If y is 1, x plus 5/12. Well, let's see what, okay. These are all going to be positive, but they're going to be increasing. And as you can see here, we're getting a table along with this. This one is fairly tricky. Okay, I didn't get that correct. Let me see if I can get a new one that I can get on the fly. X plus 1. Okay, well, here we know right off the bat, x plus 1. So whenever x is -1, this is going to be 0. So this we can see, right off the bat, we get a little bit of a cheat here that these are correct right off the bat, but automatically we're able to interpret all of these points and get both a percentage, and as we've already seen, we can get feedback on this. Some of these where we're going to look at the sinusoid plot quiz in more detail here. Some of these where we're able to, in a sort of concise sentence or two form, give more concrete feedback, we're also able to do that. So let's see, amplitude of 3, midline of y equals 4. So let's put this up on our midline of y equals 4, a period of 4 pi. So the half period is going to be 2 pi. And so let's say, I got all those pieces, but I gave it an amplitude here of 4. If I check the answer, we get tailored feedback to identify the fact that I got the amplitude. Oh, did I get this? No, I got that. Let's see. That. Okay, so I the first time I got feedback saying that it was incorrect, and it sort of gave me a hint in what direction I should go to work on getting the correct answer. You can also see there, if I get this wrong, we can also show the answer, and then this is blocked. This is turning big because of the style sheet of the presentation notebook, but you can see you can also get the correct answer, and then you're no longer able to check your answer. You say, okay, we got the answer. Now we have to move on to the next problem. Okay. So with that, the final piece of this is the sort of we have to think about is what do we do with these, right? It's great to be able to sit and practice this and work on it, work on it on your own, but do we get anything out of this? And in fact, we do. So I've gone ahead and we're going to pretend that I filled in this geometric transformation quiz. This is quizzing students on a number of rigid transformations of geometric figures, a fairly common thing for a geometry high school class. And let's see, I'll do one just to sort of see what happens here. We go down by 7, we're at -2, we go down to -9. We can see here the snap to grid is already turned on by default, just to make this a little bit easier. And if we go ahead and do this, and Right. Okay. So here the feedback is a little bit more general, but we can see, I got this incorrectly because I didn't do. Oh, I actually switched up. Here I am doing things live. Switched up the horizontal and vertical translations. But so then the question is, what are these other? What's this final button here do? So the print report button, I'll give an example just so we can walk through, and then we're going to look at one that I did already previously, just to have it ready. But basically what this report is an association of all of the problems and related information that have been ran in this particular kernel session on this particular output here. So in this case, I only did one problem. I haven't attempted anything else, but we see a description of the problem here. We have the given points, so the figure that we're starting with, a description of what the shape is, it's a rectangle, and then a transformation. So it's telling us, in a way that we can interpret later on what exactly this prompt was. Then we also have the students' guesses. We go ahead and iconize some of these just because they can be very large, as you're going to see. But so this guess was my first guess, which is the new points here after I've moved. The submitted answer, which is just the last of the guesses. In this case, these are the same thing. And then for a very quick check, did we get this problem correct or not? Did we answer it? So the way that we've gone ahead and structured this, we can see if, for example, a student has been working on this and they get this output of having done a whole bunch of problems. I think this is 7, 8. Yeah, this is 8 different problems that they've been working on. Obviously, this is a lot to look at just on its own. But because we're still working within the Wolfram language, if a student submits this or emails this to a teacher, it's super easy to take this and look at it as a data set. And this is really a result of the fact that we've made this an association and we've structured it in such a way that it's easy to work with in a programmatic way. Here, even just applying just the single function group by, we're looking at which problems did this user get correct and which ones did they not get correct. You can go ahead and you can filter them by that, and we can see really easily that all of the problems that they got correct were reflections and translations, while the ones that they didn't get correct, in this case, were just 180-degree rotations, but rotations. So we can really easily be able to pick out, oh, this student probably needs to work on rotations a little bit more. They don't have a good understanding of that concept yet. Or, they need to build their understanding and a facility with that further. So with that, I think I'm going to move on to talking about our future directions. And as Anne-Marie mentioned, we've got sort of a smattering of coverage for the existing high school and early college content. We really want to continue expanding this rigid transformations. That function actually is not quite yet published. It is available. All of our functions here are distributed to folks via a Packlet so that they can have the nice uniform structure and sort of framework underlying all of them. But so this one has been published in the Packlet, but it hasn't been published on the function repository yet. So that's forthcoming. We definitely want to build in some more statistics oriented pieces, given a data set, finding a curve that matches it with particular goodness of fit parameters. And we want to expand our calculus coverage to things like a fairly common activity of plotting a curve based on a description of its derivative or a description of its concavity. So, if you're given a number line and you say the derivative is positive on this interval and negative on this interval and so on. In terms of new functionalities, we really want to be able to expand our capacity to hopefully be able to piggyback off of some of the question object and assessment form and assessment notebook functionalities that possibly some of you all saw in the talk just before this one. And so in that vein, we want to potentially be able to facilitate students being able to submit their results rather than just having to print it out and email it to a teacher. They could have those automatically submitted to a data bin or a cloud notebook or cloud destination, so that that can be even more seamless. We want to potentially implement some more features to make these closer to a test where there's a limited number of guesses, or sort of add flexibility in terms of what teachers would want how teachers would want to be able to control these for students. Despite the fact that we have this great interface already through Wayne, we are also interested in making sort of a super function that could tie all of these together and possibly move from one quiz to the next, all within the same interface. We'd really like to also build on what is already extant in the Wolfram problem generator, and potentially be able to sort of build interoperability between these features. These do work in the cloud. They're a little bit slower in the cloud due to having dynamics in graphics, which is still an expanding area of cloud coverage. But we're sort of hoping that as we're able to move these online, that they'll also be able to interface with the problem generator a little bit more. Currently, the interfaces themselves are not computable objects. You have to use that print report button to be able to access the data that's stored in them. But it would be a reasonable thing to make them computable objects as well. And even further down the line, we'd really love to be able to think about integrating these into a learning management system or other cloud-based systems, so that they're really as easy to use as possible. With that, I think we will be wrapping. Oh, I jumped to the final slide, which I will talk about here in a second. Oh my goodness. Sorry, my controls. Okay, so at this point, we'd like to open it up to questions and feedback, and also give a particular shout out to the various other Wolfram Alpha math team members and folks who have worked on the Wolfram Alpha Notebook Edition for their contributions to this product and this project. It really wouldn't have gotten here without all of these people's input and feedback. So thank you very, very much. And while we're waiting for any questions or feedback, just in the interest of time, we didn't really have time to go over. There is a final slide here, which has some supplementary details on how these are technically implemented, related to the interfaces, how we're distributing these, and just sort of some of the considerations there, along with further details on how to go ahead and build your own dynamic interfaces if you're interested in that. And I know there have been a number of other talks, both this year and in previous years, covering, oh my goodness, these controls, covering those topics. So I encourage you to check out those as well. With that, I will open it up for questions. I'm not seeing any questions in Zoom, but do we have any questions on Pathable?
We have a question from Phil that Brad already answered in the chat, but maybe we could say out loud too about, can we author our own, which is a really good idea. And the question is like, hopefully soon, I think.
That is a great question. Yeah.
I think it'd be really great if we could have like teachers or instructors themselves be able to customize them more and expand the content of them beyond just math, because like math is what we know on the math team, but there are other things that can be interacted with and plotted. Jeremy did a lot of work developing like the framework, so they all have this uniform look, and so hopefully via other avenues we can like generalize that and maybe do some Packlet work to make them customizable further. Did you also want to talk about the question and answer stuff in the talk right before this?
Totally, thank you. Yeah, so I think that's another area where we're going to sort of be moving forward with thinking about how to make these easier for other people. The framework that we've developed does certainly make it easier now. When we have a clear vision, it's possible to get one of these out and built in about a week now with review and and that's also assuming that we didn't have anything else happening. but being able to interface with some of the other pieces that Sylvia and Stephen have been working on with regards to the question objects and sort of the interoperability with other systems that they have going on there would be really fantastic, and probably make it even easier for people to build these as it is. One comment I'll make about having external and other folks make more of these. The hardest piece of it is really sort of being able to come up with ways to grade, come up with problems that can be graded in such a way that they're tolerant of error. As we're used to plotting things on with a pen and paper, you can never be truly exact. And the same sort of thing is true here, where if you're moving a locator around, unless you have that snap to grid on, we have to think about how to build in some tolerance for human error and interface error on those. So that can be a little complicated to work through. Any other questions? Feedback, thoughts? We're open to both now, and if you have thoughts and then you want to put them in the Pathable chat after the fact, we'll definitely be able to come back and take a look at that if you have suggestions or areas where you think that these could be improved as well. So.
Okay, we have a question. The function resource function helpers, is that in WIRES? I don't know that acronym. Resource function helpers, you want to take this one, Jeremy? What is resource function helpers?
Yeah, I would love to take this one. So resource function helpers is not a standalone function. It is a applet. And for folks who want to learn more, there's details here. But it is essentially where mostly Wolfram Alpha content team members have published all of our resource functions through. If you go and look at the definition notebook for any of our resource functions, many of which come up in Wayne in particular, their code is a little bit hidden away, mostly from the standpoint of wanting to be able to have some shared utilities. There's some sorts of things that you want to be able to do that are common to various math problems. So these are accessible to anybody who wants to. If you go ahead and just look at the names that are in the context resource function helpers, these are all accessible to somebody who has ever run any of ours, because this will update and install the Packlet appropriately for you. And essentially, because we have these living in the Packlet, they are sort of the resource function is sort of the common name and the nice public facing way to access these. But if you really wanted to, you could call these just explicitly with just the resource function helpers context as well, and get the results the same as you would if you were calling it from the resource, the Wolfram function repository. So hopefully that answers the question. This is just sort of an added place for us to be able to store our information. And I will say that throughout the conference this week, with all the conversation about the Packlet repository and all of the Packlet functionality that's really being pushed out to the public, this might be re-envisioned in the next year, how these are distributed. But at least for now, it's just sort of our means of getting things out to folks through the resource functions. With that, I do see that we're over time. I'm happy to continue talking about any questions that people have. If there are no more questions right now, thank you all so much for joining. And it's been a pleasure to be able to share this with you all. And I hope you enjoy the rest of the conference.